The following content is provided under a Creative Commons license. Your support will help MIT OpenCourseware continue to offer high-quality educational resources for free. To make a donation or view additional materials from hundreds of MIT courses, visit MIT OpenCourseware at ocw.mit.edu.
Okay, so welcome to the first of our guest lecturers, and it's a very great pleasure to introduce Jesse Prinz, who's a professor of philosophy at the City University of New York. So, Jesse.
Thanks. It's really terrific to be here. Oh, is this working? Are we good on sound? Well, yeah. I think it's actually not a amplified speaker. It's just getting to the camera somehow. It's terrific to be here. What I'm going to do is talk to you a little bit about research that you've already been exposed to, research on child development, especially at infant development. And I will be trying to speak up for the anti-nativist here, the nurture side of the nature-nurture debate. Developmental psychology these days is really heavily dominated by people who believe very strongly in nativist claims, in the view that infants are born with innate representations and innate knowledge. And the way that this view is articulated, the prevailing metaphor, is that infants are kind of like scientists. And they're like scientists in that they're born with theories of how different aspects of the world works. These theories are said to be innate, and the theories are supposed to correspond to specific ontological domains. So you've been exposed to this idea in the form of the idea that infants have an innate theory of mathematics, an innate theory of geometry, an innate theory of mechanics or physical space. All of the different branches of the university might correspond to the innate endowment on this view. So infants are born with an innate psychology, an innate physics, an innate biology, and so on. Maybe innate social sciences. Another feature of the view is that this knowledge is supposed to be of a particular kind. It's supposed to be conceptual knowledge. And here conceptual is characteristically contrasted with perceptual. So infant knowledge is supposed to transcend appearances, transcend the superficial. And it's supposed to be couched in some sort of representational code that is conceptual in nature in contrast with being perceptual in nature. What is a theory? Well, you can think about a theory as a set of causal explanatory principles. So it's a theory of how things work, which things cause other kinds of things to occur, and a theory that would allow an infant to explain or make sense of her environment. Theories are also said to postulate hidden causes. So they go beyond mere appearances, and they postulate powers that can't be directly observed that are underlying the observed interactions. What does it mean to say that these things are innate? Well, one way to think about it is in terms of the organism's contribution here. So clearly infants are exposed to a rich environment and they learn things from that environment. But the idea is that they're supposed to have some sort of knowledge that's specific to these domains that is somehow intrinsic to their nature as human animals. So they're making a contribution that allows them to initially categorize the world into different classes of events and then call on domain-specific knowledge stores for thinking about those different kinds of events. And in making innateness claims, one typically tests for it in a variety of different ways. The most important of these is a poverty of stimulus kind of argument. And the idea here is you can show that the organism is making a domain-specific contribution to the attainment of a cognitive capacity by showing that there isn't enough information in the infant's environment that could, together with domain general learning resources, explain the end state, explain how the infant is able to demonstrate the capacity that she demonstrates by the age that she demonstrates it. So if you can show that the learning environment doesn't contain enough information to end up at that end state using domain general learning principles, you'd have an argument for innateness. Another way you might argue for innateness is by appeal to developmental stages. Now, it's quite well known that infant knowledge emerges over time, and people characterize various shifts in the course of development. Shifts are consistent with both a learning story and a nativism story, but shifts become evidence for innateness when you see them emerging in a very fixed way. In particular, a way that's key to chronological age of the infant. So if you can see evidence that a capacity is developing in a time course that coincides with biological maturation, that might be evidence for the innateness of the trait. And a final strategy that's used in this context is evidence for selective deficit. So if you can see that a congenital abnormality in the child leads to a selective impairment in a specific cognitive capacity, that would be evidence for the domain specificity of that capacity as well as the biological origins of that capacity, and those 2 points together would argue for innateness. Finally, just a little remark on what domains are. So one formulation might be that there are psychological structures comprising knowledge of fundamental categories. So the emphasis here might be on fundamental. The idea is that infants, among the various things that they have innate knowledge of, are going to be knowledge of very inclusive domains of objects in the world, very inclusive classes of objects in the world. And these are going to be fundamental in the sense that these very inclusive domains will give them knowledge that generalizes across a wide range of things, but not everything. So they're fundamental in that it becomes a foundation for knowledge of an entire class of things, but it's still domain specific in that it won't cover every object the child will encounter. To say this knowledge is conceptual, typically people think about concepts as amodal symbols. They're not couched in the same formats through which we experience the world perceptually. Another thing that's important in thinking about the difference between concepts and other kinds of mental representations is that concepts are under organismic control. By that I simply mean that if you have a concept of something, you can freely use it in thought. You can, in a top-down manner, apply that concept to the world. It's not just a passive response to the stimuli that are impinging on your senses. You can use it to make sense of the stimuli that are impinging on your senses. So concepts are somehow under the executive control of the organism. Okay, by the way, I'm just going to speak, but please, I encourage you to ask questions or raise issues as I go through. These are just very, very preliminary points, but what we're going to do now is begin to look at some of the work that's been used to defend this particular picture. First, briefly, though, the opposing view would look something like this. If children aren't these little scientists, if they're not born with a set of theoretical knowledge governing different domains of objects, the alternative would be that they're born with an innate similarity space, innate faculties like the sensory faculties, attention and memory, that are all domain general in nature, and perhaps too various innate biases. So I know you guys spent some time on face perception. An anti-nativist view about the capacity to perceive human faces would say we have a general capacity to parse the visual scene, and among the things we come to be able to recognize is the configuration of a human face. That said, it's not incompatible with this opposing view, with the anti-nativist view, that in fact infants have a bit more than that. Maybe they do even have a perceptual template that biases them towards looking at face-like stimuli. But on the view that there's a bias to look at faces, you don't have anything that gets to the level of cognitive sophistication of an innate theory. You can think about biases as something like an innate tendency to look at certain sources for information. And then the sources become the instructor. The child goes on to learn what she learns in virtue of how the world is. The biases just get her to look in the right place. So it's consistent with the anti-nativist picture that you have some amount of that. Anti-nativism is associated with this guy, that's John Locke, who I think you might have discussed on the first day. Another view that's very important to this anti-nativist picture is that the information is domain general. That is, the very same resources by which you learn about physical objects, about numbers, about psychology, about biology, the very same resources are used for all. On the little scientist view, you have a different set of principles governing these different domains. On the alternative view, maybe by the end of maturation, you have different principles governing these domains. But in the initial state, you're using a generic suite of learning resources to acquire knowledge of all of these. And this is Willard Van Orton Quine, who's associated as well with the empiricist tradition and contemporary philosophy. And finally, we have David Hume at the end to drive home a further feature of the alternative picture, which is the idea of perceptual grounding. It's a part of the empiricist program that opposes nativism to suppose that a lot of our concepts are actually couched in the same sort of representational resources that we would use to perceive the world. It's as if perception is moonlighting. We store perceptual representations of objects and use them for conceptual tasks. Yeah?
Could you explain what similarity space is?
Oh, sorry, yes, indeed. So the thought is when you see two objects, you need to be able to assess whether or not they're similar. And you need to do that because if we thought at the level of particulars, if the way we represented any object was simply as a totally unique thing, unrelated to any other, cognition would be too hard. It's a primary operation of the mind to classify. We say this is another one of those. And when you recognize an object as belonging to a category, you can then bring knowledge of other instances of that category to bear on that individual. Now the question is, how do you recognize that two things are similar? This, to a certain degree, has to be pre-specified. For example, just take something as simple as color perception. The ability to see two patches as both being instances of the color red, and therefore to classify them as possibly belonging to the same category, is part of our innate apparatus for vision. So if you see two birds and they're both the same color, you might initially suppose that they are members of the same category and draw inferences about one from your prior exposure to the other. So the features that we use to say two things are alike, color, shape, and so on, are part of our innate capacity to compare things and to group them together. So similarity space just refers to which kinds of stimuli will be grouped together, initially on the basis of the senses, but ultimately we might draw on more sophisticated forms of knowledge for classification. Okay, so what's the evidence that infants are born with innate theoretical knowledge? What I'm going to do is talk through three case studies, areas where psychologists have tried to argue that there's strong evidence for innate resources that take the form of little folk theories. The term folk here just refers to the idea that these theories are part of our common sense. They're part of the knowledge we have without the benefit of instruction or education. So to say that there's an innate folk physics is to say there's a conception of the physical world that we have simply in virtue of being human beings interacting in the world, as opposed to the knowledge of physics we might get from instruction in school. So what are some physical principles? The kinds of things that developmental psychologists have focused on are like this. Consider the principle of solidity that says objects can't pass through each other. So a physical object cannot pass through another physical object. If I were to try and move my hand through this wall, the wall would prevent my hand from going through. So simple thing that we certainly as adults know, according to the nativist theory that says children are like little scientists, the solidity principle might be the kind of thing infants don't need to learn, they know it innately. Another principle here that we'll look at is cohesion. So this is the idea that objects move together as bounded wholes. So suppose I start to move my legs across the room. You'll notice this peculiar thing. My arms and my head and my torso go along for the ride. So when you've seen me, your visual system has found a contour. It's used things like stereopsis to get figure ground separation. So you can now see the shape of my body. For you, that's a visual object. Now the question is, what expectations do you have about what will happen to an object when it undergoes a change? So if a change is a movement of part of that object from one location to another on the other side of the room, one expectation you have as adults is that the whole thing will come along for the ride. The nativists about this are going to say this is a piece of knowledge we didn't need to learn. So let's start to look at the experiments. Consider first solidity. So Here I want to draw your attention to some work by René Baillargeon. This is work, what I'll do in most of this review is focus on studies that I consider to be classic studies. These are textbook knowledge in developmental psychology. And of necessity, and going with the classics, I'll very often be giving you studies that by scientific standards are ancient. So this is a study from 1987. Some of you may have been in diapers in 1987, more or less. So it's an old study, but these are studies that became the theoretical foundations of what I've described as the prevailing view, the little scientist view. More recent studies have been done on every one of these topics. In criticizing these studies, I'll of course be criticizing the classics and not the cutting edge. So it really will be an injunction for you to take on the kind of exercise I'll illustrate here by reading the contemporary developmental literature and seeing if you can devise objections of your own, or on the contrary, trying to identify experiments that would withstand the kinds of objections that I'll raise about these studies here today. So here's a classic experiment by Baillargeon. It's an experiment that uses a paradigm you've had some exposure to. It's the infant looking time paradigm, where you study how long an infant stares at a display as a measure of interest or attention. And the going assumption in this research is that the longer an infant stares, the more surprised the infant is. And surprise is evidence for a violation of an expectation. So you can see what infants expect by seeing violations of expectation as measured by long looking times. What do infants consider instances of the same? If you show an infant a series of triangles, the infant will start to get bored. And the boredom suggests that they're seeing each of these as the same. Looking time will trail off here. If you suddenly show a new shape, infants get excited. They'll stare at this item longer than they stared at this item. The looking time for this will be comparable to the looking time for this. That's a suggestion that infants are drawing category boundaries that include all the triangles on the one hand and squares on the other. So that's the basic logic of these studies. How does this apply to physical knowledge? Here's an example. In this study, infants are exposed to the following display. They see a board, just a flat board lying on a surface, and the board slowly lifts up and keeps going and finally rotates 180 degrees, so it's now lying flat again. So basically they see a board that goes like this and ends up flat. Very, very boring display. It's initially exciting to infants. They look at that a few times, and after they've seen it a few times, they are then given a new variation, and the question is, what will the infants expect in the new variation? This phase of the experiment is called the habituation, or sometimes familiarization, depending on the design. Here is where infants are getting used to seeing a certain kind of display. This phase of the experiment is called test. In one test condition, an object is placed now behind the board. I just put a little duck there. It could be anything you like. The board goes up and keeps going, but it stops. Why does it stop? Well, it stops because it's hit the duck. It can't continue to fall. This is just what adults would expect. Why? Adults know the principle of solidity. They know that the board can't pass through the duck. The duck is a solid object. It has to stop. So even if adults have been looking at this and they know this board is inclined to rotate 180 degrees, they know that's just not possible in this case. So adults are likely to expect the board to stop here. In another test condition, infants see this display, this sequence. Here the board rises up, the duck is there as in the first test, but now the board continues to 180 degrees. It passes straight through that object. So if an adult saw this, they would say it's a magic trick. They would say, through some clever sleight of hand, the experimenter has removed the duck. They would be very amused by this. They would say, that's really a violation of my physical expectations. Physically possible event, physically impossible event. What's exciting about this experiment is that Baillargeon is pitting physical possibility based on knowledge of folk physics against perceptual similarity. Here's why. If you look at this sequence, it's more perceptually similar to the habituation sequence than this one is. Notice that this frame and this frame are just like the final two frames of that sequence. If you've just been looking at a perceptual display that ends up like this, your perceptually based expectation might be to see more of the same. If infants were going by perceptual similarity, this should be the weird one. They should stare at this one because it's more perceptually dissimilar from what they've just been staring at. If they're going by physical principles, the one that should really surprise them should be this one. Just like adults, they should say, that's bizarre. How the heck did that board pass straight through the little ducky? And sure enough, that's what Baillargeon found. So when this experiment was done, it was quite exciting because it suggested that infants as young as 5.5 months already understand this principle of solidity and are not going by perception alone. Okay, so that's a classic study. The existing literature on this study is filled with various kinds of concerns and objections, and I'll just mention one. One objection to this, actually I'm going to mention two. One objection to the study is that infants like movement, and they may, when they're looking at movement, they may just get excited. Movement is exciting to them. So one possibility is that just given the movement bias, they're going to stare at this one because there's more motion and it's a more dynamic display. But I think the more interesting objection comes from Schilling, and it goes like this. And it's a technical objection, but the principle is fairly simple. As I mentioned before, the habituation paradigm works on the assumption that infants stare more at what they find surprising. In actual fact, this isn't entirely true. What you really find in actual fact is that in staring time and looking time, infants begin by staring more at the familiar, which is to say, there's a kind of curve, a bell curve, where our infants initially get excited by seeing more of the same. And after they've seen enough of the same, then they start to trail off and get bored. So if we go back to our triangles over here, and you are measuring looking time, you might find that looking time actually increases initially, but then trails way off. There's this sort of excitement. Freud talks about the repetition compulsion. You've all seen this in young children. You can see it in babies too. Seeing more of the same, they seem to have an incredibly high tolerance for repetition. And it seems to be amusing to them to see another instance of the same. So what may go on here is you initially get preference for the same and ultimately trail off, and the infants get bored. And then you get looking time increasing again for novelty. Well, suppose that when the infants stare at this event, it's not because they find it surprising, it's because they're delighted to see something familiar. How do you overcome this confound? How do you make sure that their staring time is a function of excitement about novelty as opposed to familiarity? Answer, you double the number of habituation trials. In Baillargeon's initial experiment, she used only a small number of habituation trials. If you double them from 4 exposures to that board just going up and down to 8 exposures, that board going up and down, what you find is the results at test reverse. Now infants are more surprised to look at this one. So there's a technical problem with this study that vitiates Baillargeon's interpretation. It's very possible, given Schilling's replication or failed replication of the experiment, that infants are actually going by perceptual similarity and end up being surprised by this one that is consistent with physical principles. Moreover, you can find evidence from older kids that children are not that sophisticated when it comes to reasoning about solidity. So for example, in this experiment by Bruce Hood, this is with 2-year-olds. 2-year-olds see a ball being dropped into a box like this. Then the box is open to reveal that it's just a big empty crate and the ball is sitting on the bottom. Then in a test phase of the experiment, the kids are shown the same box, but now the experimenter puts a little bowl in the bottom of the box, then puts a shelf in that covers the whole surface, sort of midway through the box, and puts another bowl on top of that shelf. The box is covered, the ball is dropped, and now the cover is removed, And the question is, where will the 2-year-olds look for the ball? Now, as adults, we would look for the ball here. Why? We know a ball can't pass through this solid shelf. But the 2-year-olds in the study look here at the base. They're going by the perceptual similarity. They've been exposed to a ball going to the bottom. They expect to see the ball in the bottom. They overcome this, but these kids are 2 years old. The experiment we were just talking about is with 5-month-olds. So if 2-year-olds still don't have solidity, we should be a little suspicious of Baillargeon's claim that it's present at 5 months. Another example, this is another classic study. This is Kelman and Spelke. And here you see an object, a rod, passing back and forth behind an occluder like this. At test, infants are exposed either to a solid rod, the occluder is removed, they see either a solid rod or 2 separate rods moving together. Remember I said when I move across the room you expect my torso to go with me? The same sort of thing here. If you see 2 bits of an object moving together, you expect them to be connected. So this is sort of the inverse principle of the principle that governs your expectations about my walking across the room. If I walk across the room like this and you see my head and torso moving with my legs, and now I open my sweater and you would discover there's a giant gap here, you would be mystified. How the heck did my arms follow my legs if they're not attached? So the expectation of attachment is probed here. Infants are surprised to see this, just as adults would be. So in each of these studies, you're going to see infants showing the same surprise response that adults would show, suggesting they already possess the knowledge. Kelman and Spelke did this with 4-month-olds. It's been replicated with infants as young as 2 months old, showing that they seem to have this principle that objects move together as bounded coherent wholes. Now, what to say about this? One possibility is that the looking time is really a function of display complexity. So remember the 2 test displays. This is 1 object, this is 2. This is a simple object, this is a more complex one. We know quite well from other studies that infants have a preference for staring at more complex objects. So if you just look at the baselines, which are actually reported in the initial study, you can see that infants are going to stare more at this object, simply because it's more interesting, it's more complex. So the looking time might have nothing to do with physical expectations. It may just have to do with baseline differences in simple objects versus complex objects. Another thing is, maybe these rules are learned by observation. Even at 2 months old, infants have seen a lot of stuff. And every time they've seen things moving together, they've seen connective tissue between those 2 things. It's very rare in the real world. Maybe flying birds do this. But it's very rare in the real world to see 2 objects moving in sync when they're not actually physically connected. So the claim that infants are not exposed to stimuli that would be sufficient for arriving at this knowledge has not been demonstrated here. And I can't emphasize this point enough, because I think if you read the developmental psychology, you'll actually very rarely see something presented in the form of a good poverty of stimulus argument. To do that, the experimenters need to show that the stimulus is impoverished. What does that mean? They need to show that infants are not exposed to perceptual displays, objects in their surrounding environment that could be used to extrapolate the relevant physical principles. But it does seem that, given that all of the perceptual displays we're exposed to conform to these basic principles of physics, like solidity, like objects moving together as coherent wholes, there is no poverty of stimulus. The stimulus here is very, very rich. Infants are exposed to a physical world that does conform observably to physical principles. So the real question is what's going on prior to this exposure. And in fact, if you do the study that Kelman and Spelke did, the one we just saw, with newborns, you don't see the mature pattern. Infants who are newborns actually seem to be surprised at the whole object as opposed to the 2 separate objects. So it does look like there's a transformation over developmental time here. Moreover, even if you think this ability is innate, there's no evidence whatsoever that it's conceptual. I mean, we do know that the visual system is capable of completing gaps between objects. There's something called amodal completion. So if an object is partially occluded, the visual system does a kind of filling in, where it tells you how these lines will continue below the occluded surface. Suppose we say that that is innate. Suppose we grant that. That seems to be granting something far less than an intuitive physics, a naive physical theory. That's just a principle of filling in the visual system. It doesn't involve anything like conceptual knowledge of physical principles. And in particular, it's not knowledge that the child could bring to bear in this top-down way to explain her world. So it doesn't look like theories in the sense that adults have theories, where we can clearly articulate some general principle and apply it to the world, think about it, reflect on it, correct it, and so on.
So just
Yeah.
on that point, there's evidence that, I mean, old evidence that the infants have the same, respond in the same way for a version where the stimulus is presented in a tactile way. So where
Yeah, so there's an experiment that Spelke was also, Strary and Spelke, where, I mean, there are various versions of it, but one version of it is they're presented with it visually and haptically. In those cases, there are two moves that are available for the empiricist to make. One of them is to simply concede the result and say, look, unlike what Locke had claimed, we do have innate capacities for transferring information from one sense to another. And to a certain extent, that seems to be plausible, true, even sort of evolutionarily demanded. So for example, we know infants just after birth will orient their eyes to a sound. So if you snap by the ear of an infant, it will shift its eyes. Somehow its visual system is able to use sound as a cue. And likewise, it may be that going from a felt shape of an object to a visual presentation of that object is innately hardwired. Now, when you say it's innately hardwired, you're not conceding anything like this set of scientific principles underlying a folk physics, nor are you conceding anything conceptual. When Spelke and Strary wrote the study, their conclusion was this is evidence that empiricism is false. Why? Not because the knowledge is innate, but they said because it shows that infants think using an amodal code. They think using concepts that are not specific to the senses. But it seems to me that's a bad inference from the study, because in fact, when you find that infants can go from touch to vision, it doesn't show that there's some third code that they're using to understand what these two have in common. It just means there's an innate mapping rule that tells them if they visually experience something, they should expect to tactily experience something, and conversely. One way to think about it is if I give you a passage of poetry in German, and I say, can you translate this into English? And you happen to know several languages, there's no reason in the world why you should translate it into Italian first. You can go straight from German to English. And likewise, if I give you something in touch, there's no reason why you need to translate it into an amodal code before going to a visual code. If we just have codes for the 5 senses, or the 6 or 7 senses that we have, translation rules between them, we don't need to postulate any kind of amodal system of representation that goes beyond the senses. It's a nice example. It's a nice study to bring out, in part because I think it is going to be a straw man theory if the empiricist is painted as somebody who's not going to allow for anything that's innate. One way to think about the nature-nurture debate is it can be constructive, especially in areas where nativism has become the dominant view, to be what I would call a methodological empiricist. And by a methodological empiricist, I just mean somebody who's not convinced yet one way or the other that something is innate or learned, but rather somebody who, when confronted with evidence for innateness, tries to come up with a learning story as an alternative. In the course of this process, we'll eventually hit studies where the learning story just isn't going to be supported by the evidence. And I think that might be one of the places where that's true. Another domain where innateness claims have been explored quite intensively is in folk biology. And folk biology includes basic principles as well, but one of the important concepts in folk biology is that biological kinds differ from non-biological kinds, that animals differ from artifacts. So here, as Bosco sits in his little train here, he's looking at the mouse. He could distinguish the mouse from the train. The train is one kind of object, the mouse is another kind of object. And the idea of the folk biology view is that when you draw this distinction between artifacts and animals, your expectations differ. You draw on different innate theories to think about these two kinds of things. And in particular, Bosco is going to assume that animals have hidden essences, have features that are essential to them independent of their appearance, that can remain constant as that appearance changes. Artifacts sort of wear their essence on their sleeves. You can tell what's essential to an artifact by just watching it in action, seeing how it behaves. What's essential to artifacts is their function, and their function is readily observable. What's essential to an animal is its innards, things inside of it, which can't be directly observed. This differentiation between artifacts and animals has guided a lot of research on children and infants. One of the pioneers of this work is Frank Kyle at Yale. And a lot of Kyle's research has focused on a kind of experiment that involves transformations like this. A child is told, consider this creature here. And now something happened to this creature. Some people took this creature and they painted it so it's black. And then they painted a white stripe down its back. And then they attached some really smelly sacks to it so that when you come near it, it sprays out this terrible smell. And at the end of this manipulation, it looked like this. Question: is this a raccoon or a skunk? And the adult response is that, well, it looks like a skunk, but I know it's really a raccoon. It's just a painted raccoon. So if told that the transformation involves paint and smelly sacks being affixed to the animal, adults think that it's retained its essence. They go beyond superficial similarity. Young kids don't do this. They say it's now a skunk. They think a superficial transformation leads to a change in essence, a change in identity. When Kyle first showed this, it looked like strong support for the empiricist view that says kids are using similarity at first, they're going by superficial appearances, relying on perception, and only later come to recognize that there are underlying factors that may be more important for object identity. But in further work, Kyle was able to discover that even very young kids are showing some sensitivity to hidden essences. The view is called psychological essentialism, and it's just the view that certain things have essential properties that are not available to view. Psychological essentialism is not observed in the transformation from raccoon to skunks in first graders, but or in kindergartners. But if you go to another transformation, like this one, they do show evidence for psychological essentialism. So here kids are told to consider a toy bird that looks like this, and then they're told that some feathers are attached to it, and that a little music box is attached to it that makes it make a very melodic tweeting sound, and a little engine is attached to it so it can flap its wings and fly from tree to tree, and by the end of the transformation it looks like this. And they're asked, is this a real bird or a toy bird? Now, in this case, the kindergartners, who are the youngest kids that Kyle has tested, say it's a toy. They say, I don't care what it looks like. It looks like a real bird, but I know it's a toy. So they're going beyond the superficial appearances and insisting that its essence is determined by what it started out as, not by what it happens to look like at the end of this superficial transformation. So Kyle says this is evidence that kids don't rely on similarity alone. The youngest kids he's tested go beyond superficial appearances to make decisions about what's going to happen in these transformation cases. He calls the opposing view the original sim, for original similarity. The idea is that when we're born, we first classify objects on the basis of superficial similarity and only later come to think that there are properties that transcend appearances. He says this experiment is evidence that even kindergartners are not driven by similarity alone. Now, in response to this, one thing to point out is that kindergartners are really old. They're really old. They've been exposed to lots of things before, including certain explicit instruction. So they're told toys are not real. Young kids have a tendency to anthropomorphize their toys or treat their toys as animate. And adults will tell them these toys are not real. Adults will point out that their toy dog is different from their pet dog. And they've also seen a lot of realistic toys, so they know that even a toy that looks very real is not real and can't become real. But in contrast to this, they've seen lots of cases where one animal transforms into an animal that looks very different. Moths and butterflies begin as caterpillars. They've seen babies grow up into adults. So they've seen lots of cases where something that looks one way transforms to look a different way while retaining its identity in some sense. So within the biological domain, they're exposed to cases where transformations don't change identity. But within the cross-domain case, they're not exposed to any such cases. So the results really nicely track a prior experience. And ask the question, Kyle has worked with kids who are in kindergarten. What if you go to younger kids? Do they assume that animals can't turn into artifacts? Here's an experiment that bears on that. It was an experiment designed for another purpose, but it actually illustrates the point nicely. This is an experiment done by Zhu and Carey, and the infants in this experiment were younger than 10 months old. So they're really infants, they're not linguistic yet, and the question is, what are their expectations about transformations? So here's the study. They see a little board like this, and they see a little truck come from behind the board. Then the truck goes back in, and then they see a little kitten come out the other side, and the kitten goes back in. Now the question is, what should we expect to see when we lift the board? Of course, as adults, we should expect to see a truck and a kitten, because we know that trucks and kittens are different kinds of objects. But with the infants, we're no more surprised to see a truck and a kitten than to see just a truck. So it was consistent with infant expectations that the truck could transform into a kitten and then back into a truck again. Now, we're not directly probing their beliefs about object identity or hidden essences, but the idea that there are tolerable or perfectly acceptable transformations from one kind of thing, artifact into animal, seems to be our initial state. And learning these artifact-animal boundaries come only with later development. Okay, let me, in the last couple of minutes, talk about one other domain, which is folk psychology. So folk psychology is our capacity to attribute mental states to others. So here's one experiment that's also a classic experiment done by Gergely and colleagues. Here's what the experimenters want to show. They want to say infants have an innate theory according to which objects of a certain kind have goals, intentions, and beliefs. So they see this ball leaping over a boundary and making contact with the other ball. Now when infants look at this for a while, or I should say when adults look at this for a while, they begin to say, oh, it must be that the red ball has the goal of touching the blue ball. So go to test, and if the red ball has the goal of touching the blue ball, then when the barrier is removed, it shouldn't do this. It should instead move like this. This one is more perceptually similar to the habituation, but this one is more conceptually similar. You've attributed a goal to the ball, and now the fastest way to achieve its goal is to move on a straight line. And like adults, infants are extremely surprised to see this, even if they've just been looking at that display. So what's going on here? Gergely says this is evidence that infants are attributing goals to objects. That's folk psychology, attributing mental states to things. But the problem is this is a very strange, unusual motion. People don't observe objects just leaping spontaneously in space. In fact, in the habituation, they keep varying the height of that barrier, and the ball always closely tracks the height of the barrier. People see objects rolling along a surface, but not spontaneously leaping up like this. So this is actually a pretty bizarre display. Infants see balls rolling on flat surfaces all the time, so this is a familiar display. So actually there's a non-psychology involving interpretation of these results. One final experiment. This is the one, there's a reading you might have gotten on this one. This is Baerjan and Onishi. It's an infant version of what's called the false belief task, which is a standard task used in older kids to measure whether they can attribute mental states. This woman has a piece of watermelon. She puts it in a box. Then a little wall comes up, but you can see over that wall, and she notices that the watermelon hops out of the green box and moves into the red box. Now the question is, where will she look? Will she look for the watermelon in the green box or in the red box? Adults and infants both expect her to look in the red box. Why? She saw the watermelon move. So infants are surprised. They stare longer when she reaches into the green box. Now here's the crucial test. Same startup. She puts the watermelon in the green box, but this time a wall comes up that prevents her from seeing what happens next. Just as in the first case, the watermelon migrates from green box to red box. And now we have test again. The wall is taken down. And the question is, where is she going to look for the watermelon? So where should she look? Green box or red box? You as adult responders? She should look in the green box because she doesn't know that watermelon turned into a crazy animate watermelon and hopped from box to box. So she should look in the green box. Well, infants show the same expectation. Infants are very surprised when she looks in the red box, even though they had been surprised by her looking in the green box before. So Bayerjean says what infants must be doing is they're attributing a belief to her, the belief that the watermelon is in the green box. In fact, they're doing something even fancier than that. They're attributing what's called a false belief. That's to say, they're attributing a belief that the infant herself knows isn't in fact true. So the infant needs to keep track simultaneously of how the world is. The infant knows the watermelon is in there, but also how she takes the world to be, what her beliefs are about the world. So false belief is a very strong, powerful measure of whether infants understand the concept of belief, because like beliefs, like the nature of beliefs, somebody can believe something that isn't true, that departs from reality. So this, Bayerjean and Onishi interpret as evidence for the claim that infants are attributing beliefs. The problem with this, and this came out in a review by Josef Perner, is that actually the study can be entirely explained by associative learning. So if you look at this case, the last time you saw object, location, and woman together, you have the red box. So just imagine that infants are keeping track of correlations, which objects we're seeing together. The most recent correlation between her and this object is with the red box. In this situation where the screen covers the woman, the last time you saw the woman with the object was in the green box. So most recent combination of woman and object predicts the looking time results. And that's just a perceptual association effect that's quite easy to demonstrate in infants independent of this. So where does this leave us? I think what we should say about these studies is that in each case, when you read an article in developmental psychology journals, you'll see the author offer an interpretation. More often than not these days, the interpretation will be that the study shows innate knowledge of principles of the kind that we've been talking. And then the analogy you'll typically find in the background is the idea that the infant is like a little scientist who's constructing theories in accordance with these different broad domains. The alternative view is that infants just have general perceptual sensitivities and use those to parse and organize the world and come to learn theories only later on in development. René Bayerjean, in response to this kind of objection, says that these experiments are actually based on predictions that the theory view has. The empiricist can come back and try and reinterpret them, but that sort of post hoc, the empiricist might always be able to find some perceptual story to tell, but the experiments are generated to test certain assumptions that the nativist has made, and the tests come out positive. But I think we shouldn't allow this response because, in fact, the very principles that the empiricist is relying on here could be used to generate predictions too. And empiricists could run studies that parallel these to show what kinds of perceptual similarities infants use in keeping track of the physical world. I think it's good for the science to try and generate empiricist reinterpretations of the nativist experiments. Ultimately, the truth is probably somewhere in the middle, but only by playing both sides of the field can we arrive at that truth. If we simply assume nativism, we'll be biased towards overly intellectual interpretations of the results, and we'll end up with a theory that might actually overestimate how much knowledge infants have. So here's what I would suggest in closing as a kind of homework assignment. Open an issue of a developmental psychology journal, like the journal Developmental Psychology or Child Development. Find an infant looking study. Look at how the authors interpret the experiment and see whether you can play the game of being an empiricist and come up with an empiricist interpretation. Very often the authors will have anticipated that alternative and controlled for it, but you'll probably be able to come up with some interpretations the experimenter didn't control for. That itself could become the foundation of further experiments, and you might be convinced by the results of those further experiments that you should be a nativist after all. But I think you'll find in performing this exercise that the ease with which one can generate empiricist interpretations for the textbook studies in contemporary developmental psychology suggests that the empiricist explanations have been prematurely foreclosed. So I'll stop there. I'm sorry I didn't leave more time for questions. If anyone has something super quick before others run off, but otherwise I'm going to be around for the lunch hour now, and I hope people will come around and talk then.